Welcome to my next session on Six Sigma series. Today we are going to learn about the process measurement and analysis. This is unit number 3. I, Dr. Rohan Prabhakar Devale, welcome you all. Here for this particular unit, the objectives are to understand the process metrics, data collection and data summarization, explain measurement system evaluation and process capability evaluation, comprehend benchmarking and project review measure phase, analysis of statistical methods in Six Sigma and a bit of probability distribution, and discuss value stream mapping, root cause analysis, and cause effect diagram. So, we will start with introduction. Measurement is key and it is essential in Six Sigma. The goal of measurement system analysis is to preserve the integrity of both data collection as well as data itself. Incorporating MSA, that is measurement system analysis. So incorporating MSA in Six Sigma methodology and quality management is critical for the proper data analysis and future decision making. This measurement system analysis is a tool for analyzing and variation present in each type of inspection, measurement and test equipments used in Six Sigma. Measurement system analysis includes various techniques to assess the performance of manufacturer's measurement system. Measurement process includes several measures such as softwares and variety of sources for potential variation such as personal and environmental factors. Goal of the measurement system analysis is to preserve the integrity of both data collection as well as data itself. With the knowledge that is provided by data analysis, companies are better informed on the implications for the measurement error, which drives decisions about individual product and processes. So, in this particular unit, we will discuss the process matrix, data collection, data summarization, measurement system evaluation, then a process capability evaluation, and benchmarking. So, we will start with the main part, that is process measurement and system analysis. So, the foremost purpose of measurement system analysis is to scrutinize the legitimacy of the measuring system and attempt the curtail of the leading process variation due to measurement system. It instruments the excellence of the measurement system. Companies usually contemplate the measurement data in creating decisions in regards to the process for the business. That is the reason accuracy of data is mandatory here. Accurateness of data considered to be one of the essential necessities in dynamic process. It helps to assess consequence of the measurement system on data being measured and collected. Incorrect decisions will be taken if there is lack of correct data. Monitoring and measuring resources are one of the most significant obligation in quality management system, that is ISO 9001. Once again, I have to admit one student. Okay, so we will continue. So basics of accurate management system or measurement system. So the purpose of measurement system analysis is succeed to a measurement system for use involving clean accurateness and the consistency. Measurement considered to be precise in the case of inclination is the middle around the definite value of the object being measured. Now there are various types of measurement system analysis. So measurement system analysis and measurement is considered to be precise in case they vary from another in a minor extent. So, measurement system analysis can be broadly classified as process variation and measurement variation. In the measurement variation, we are looking for the accuracy, that is bias, linearity, and stability. Also, we are looking for the precision, that is repeatability and reproducibility. So, we will see these features one by one in detail. We'll start with accuracy and bias. So, what is accuracy? So, as you see in the left hand side, accuracy is the variance between the accurate average and the observed average. If the amount of average varies from the accurate average, then the system is considered to be faulty or inaccurate. Then next is bias. As you see in the right hand figure, bias is the variance between observed range measurement to the true or referred value. To measure the bias, initially we require to measure some part for numerous times, then compute the average of measurement. So simple bias equal to average of measurement value subtract by reference or true value. Next are linearity and stability. So what is linearity? Linearity is variance in bias or variance in bias value over the normal operating range of the measuring instrument. Alternately, it is the variance in bias over the operating range of measurement equipment. Stability. Stability denotes to the volume of the measurement system to yield the same values over the time while measuring the same sample. Alternately, it is the variance in the average of at least two sets of measurement with an instrument over time. A measurement system is considered to be stable in case there is no distinct reasons of variation distressing the measurement system bias over time. Precision. The precision of the measurement system is the amount to which recurrent measurement under unaffected circumstances display similar consequences. Alternately, it is the precision denotes the closeness of two or more measurement to each other. Next is repeatability. One second, I have to admit one student. Okay, next is repeatability. Repeatability is the variation between consecutive measurements of the similar part, identical trait by the same individual by means of same instrument. Alternately, it is the amount of variation we observe during the measurement accomplished by same individual on the similar part using the identical instrument. Apart from that, we are having the reproducibility. It is the reproducibility is the variance in the average of the measurement accomplished by various individuals by means of similar tools during measuring the same characteristics on identical portion. Alternately, it is the amount of variation observed during the measurement of various individuals on the same portion by the means of instrument. Now, how much measurement error is acceptable? So, according to the Six Sigma and according to the AIAG 2000 anomaly, following are the thumb rule for accepting the measurement system. So, below 10% error is acceptable. 10 to 30% error denotes the system is satisfactory. Also, we need to consider that importance of the application, measurement device cost, repairing cost, and other aspects also. Considering over 30% error is unacceptable. Hence, you should improve the measurement system. Next part is measurement system evaluation and analysis. So, identifying the category of data collection, it is essential to recognize whether the collected data is instant or discrete. Identify the amount of appraisers, amount of sample parts, and also the amount of recurrence measurement. Greater number of parts and recurrence measurement deliver consequences with a greater degree of assurance. But factors like time, cost, and disruptions should also be taken into consideration. Use appraisers who usually accomplish the measurement and who are acquainted with approaches and measures. In specific, ensure that all the appraisers maintain the same process of measurement. So choose the sample parts to characterize the complete process range. This is very important to be considered. In case possible, making the precise measurement site on every part should be done. This will bring down the influence of within part variation. Additionally, has uh, it has to be taken into consideration that measurement instruments should have sufficient discrement. Now we will learn about process matrix. Process matrix is a significant tool for firms that wish to track, access, improve their overall operation performance. There are many Six Sigma metric or measures of performance used by Six Sigma practitioners. Mentioned below is a list of normal methods where business uses Six Sigma metrics. That is, you can see on the screen, improving efficiency, benchmarking, ranking, and improving customer satisfaction. Now we are having various tools for that. Before that, we'll just learn about 10 Six Sigma metrics, that is defect rate, process cycle time, lead time, process measurement, process capability, rolled through yield, then X bar utilization, CPK, and material control are there. For data collection, the following are the two maintained to plan the data collection for Six Sigma. Questions are to be identified which requires definite answer, and identify the type of data which is available. So data summarization is there are various processes for summarizing the data collection. First is box plot. As you can see on the screen, the figure shows box plot. So it is also known as box and whisker plot or 5 number summary. It consists of 5 points of interest, which are the quartiles, the median, the highest and lowest value, and displayed data distributed within a specified range. Next is a stem and leaf plot. It splits each number into a stem, all numbers but least digit, and a leaf with the last digit. Like for the numbers 45 and 59, there are 4 and 5, and the leaves are 5 and 9. So just consider the number 32. So for 32, as the 10 digit number is 3, so we are having stem of 3 and we are having leaf of 2. So this is how 32 is placed in the stem and leaf diagram. Once again, I will just see to whom to admit. Okay, so this is about stem and leaf diagram. After that, we are having histograms. Histograms portrays the frequency in data as adjacent rectangles founded over the intervals with an area proportional to the frequency of the observation in the interval. Now we can see the highest peak. So from the highest peak, we can calculate the mode. So mode is between the highest peak, that is it is between 75 to 80. So we have seen box plot, we have seen stem and leaf diagram, then histogram. Now we are having run chart. These run charts, it exhibits in what way a process performs over a specific period of time. Data points are plotted in chronological direction and associated as the line graph. So this is called as run chart. Next is scatter diagram. It portrays various x, y coordinates, data points, and signifies the association between two similar variables on x-axis and y-axis. Apart from that, we are also having normal probability plot and Weibull plot. So there are various statistical methods which are used in Six Sigma. So types of statistical analysis that is displayed on the screen. So statistics comprise of principles and procedures for aggregating, analyzing, understanding, portraying the data in an expressive manner. Statistic assistants assist us to comprehend the conduct of data and detect enhancement perspective and forecast forthcoming process performances. So these are the types of statistical analysis. It can be split into the descriptive statistics and inferential statistics. Again, for different descriptive statistics, we are having central tendency and measures of dispersion. So for central tendency, it is the statistical measure which is used to identify the center of the distribution of data. Like if we are having 10, 20, and 30 as three numbers, then the middle frequency will be 20. As we are having 10, 20, and 30, so middle will be 20. So based on the situation, the measures of central tendency, we can find out mean, median, and mode. So you must have learned mean, median, and mode, very simple basic concepts. So mean is the sum of all the data values divided by the number of data points that is known. So formula here will be sum of observation divided by total number of observation. Then we are having median. So median is the middle value of the data set arranged either in ascending or maybe in descending order. In case of data, it consists of even number. Median will be the average of two middle values. So median will be the n by 2 term plus n by 2 plus 1 term divided by 2. So if there are again three terms, 10, 20, and 30, so middle will be 20. So median also here will be 20. And if there are four like even numbers like 10, 20, 30, and 40, then median will be the average of in between two, that is 10, 20, 30, 40. So middle in between we are having 20 and 30, so average of 20 and 30 will be 25. So here in this case of 10, 20, 30, and 40, median will be 25. Also we are having mode is the value which occurs frequently in the data set. So large number of occurrence in the frequency is known as mode. So we are having the central tendency as mean, mode, and median. Apart from that, we are also having the measures of dispersion. That is, what is the range of data, what is variance of the data, and what is the standard deviation of data. Apart from that, we can calculate kurtosis, shape of the data, symmetric distribution, and all. Also, apart from that, we are having some t-test, ANOVA, and regression analysis, but that is the pure part of a statistical analysis, and that is not there in your syllabus. Okay. So apart from that, we are having the probability distribution, that can be normal distribution. Data can be normally distributed. Data can be distributed in the binomial form. The next is root cause analysis. Root cause analysis is very simple technique in the Six Sigma. Okay. Root cause is considered as a major aspect which is used to eliminate the non-conformance from a process. So there are many methodologies, approaches, and techniques for conducting root cause analysis. So that includes events and causal factor analysis, then change analysis, barrier analysis, management oversight, and risk tree analysis. So first we'll start with the Kepner-Drigo problem solving and decision making approach. This model provides four distinct stages for resolution of a problem. So these four stages are, once again, I will admit one student. These four stages are situation analysis, problem analysis, solution analysis, and potential problem analysis. The next is root cause analysis, that is RCA tools. So we are having the fishbone diagram, Ishikawa fishbone diagram. So it is also called as Ishikawa cause and effect or Ishikawa fishbone diagram. It is one of the standard tools for root cause analysis. It is also used to recognize the numerous probable sources which lead to the process under investigation. Then we are having five whys, another well used tool for root cause analysis. It is also called as Gemba Gembetsu. It is Japanese term. It is a method that discover the concealed reasons of the precise problem by recurrent ask why. The number 5 is not constant here, but normally the root cause will get identified from the 5 whys. Then we are having flowchart. It is used to map the process steps through various sections, which is very much obliging to recognize the cause position of the defects. We are having Pareto analysis. It is normally taken into account at the time of brainstorming sessions to set priorities to a provided probable reasons of adverse occurrences. The principle of this chart is 20% of consequences causes 80% of the effects. Last is we are having scatter diagram. This tools enables confirming relations by providing numerous variables on the graph. So this is the first, that is cause and effect diagram. It is also called as Ishikawa cause and effect or fishbone diagram. Most cause and effect diagram normally consider like an array of probable reasons for any issue analyzed. In this, uh, in the manufacturing industry, they are also referred as 6 M's, that is methods, machineries, materials, then measurement, mother nature or environment or manpower or people. So on the screen you can see one of the example, a cause and effect diagram. Infrequently, manufacturing analysis will consider two types: maintenance and management. In the service industry, these are described as 5S, that is surroundings, suppliers, systems, and skills. That is noted or in the above diagram. Apart from that, we are having, suppose it is the product case in the cause and effect diagram. So in the marketing industry, the cause and effect diagram will comprise of 7 P's of marketing, like product, price, place, promotion, then physical evidence, people, and processes. So this will be the in case of marketing. Now this is very small unit, so we are moving towards summary. So very small things we have learned. The foremost purpose of measurement analysis is to scrutinize the of the measuring system and attempt to the curtail to leading of the process variation due to meant system. Monitoring and measuring resources are one of the most significant obligation in the quality management system. Purpose of measurement system analysis is to succeed a measurement system for use of numerating in the consistency. Accuracy is the variance between the accurate average and observed average. Linearity is variance of bias value over the normal operating range of the measuring instrument. Process matrix is significant tool for firms that wish to track access and improve their overall operational performance. Then a defect rate can be calculated by dividing the total number of defects by the total number of units. There are four primary categories of process enhancement tools: fishbone diagrams, then five whys is used for in-depth analysis of the root cause problem. The analysis process is very easy. The requirement to ask five why this five times. So the Pareto analysis illustrated from a brainstorming session with the project team. It is formed to display the impact of various incompetency. A Pareto chart taken into consideration that 80% of the problems yield to the 20% of insufficiencies. A cause and effect diagram reviews the events which are previously taken place or is yet to occur. So with this, we have finished this particular chapter.